So let's solve this problem in Java, the algorithm that we have already deduced in our previous video. So I have got my IntelliJ open. Let's start solving this problem here. I take the same method as given here. Okay. Now here we have seen that we are maintaining this uh, like in a form of 2D array, but I think we can have a better optimization that we can only go with 1D array having only 3 elements. And for the next of the for if we move for the from 0 to 1 and 2, we will keep on updating that DP array of only 3 elements accordingly. So let me show it how. So let me create one 1D array only of 3, where each 3 elements would be representing one house, one one row, like this. And we'll keep. And when we move to first, we will update with the 3 elements with this one, with the formula which is we have derived in our previous video, and similarly for this. Okay, so let's start doing it. So firstly, I will. Okay, let me use a for each loop. Okay, let me a little bit format it. Okay. Okay. So each, because it's a 2D array, right? So costs here represent like, so for the very first index is for house 1, having 3 elements of cost for red, blue, and green. So it's a 2D array as given as. So now we have to calculate, say, for example, DP0. DP0 is starting with the first house, the 0th index. So DP of 0 would be cost of 0, right? Cost of 0 is here is, we start with the very first one, it would be 14 itself. This is cost of 0th index. Here we are dealing with the first row right now. And we have to take the minimum of DP of 1, right? Because if we are choosing red, we can choose only DP of blue or green. Now for the very first case, right, because by default the DP would be initialized as 0, 0, 0, right? So that's why when we initialize it, this would be giving me the this math.min will only give me 0. So that's why for the very first house, we have already calculated that we will choose whatever the cost has been given. So for example, for red is given as 14, blue 2, and green 11. It would be same as it is. Similarly for DP1, maybe I will just copy paste these two. Not for DP1, right? DP1 would be cost of first and minimum of 0, which is red, or 2, green, which is correct. And similarly for, say, DP of 2, it would be cost of 2, which is the cost given here. For example, cost of 2 is 5, for example, for 1, and for 0 it's 11, like this. And math of minimum of 0, because this is for green, we can only choose red or blue. Red is 0 and blue is 1. So here we got this new updated cost for DP0, DP1, and DP2. DP0, DP1, and DP2. And then similarly we update our DP array with the values calculated. Again, I will do, sorry. Yep. So it will be 1, 2. Right. So here, this is all of the formula about. We have using a more efficient way because we don't want to have a 2D DP array. We can just do the same thing using more efficient DP array of only 3, and we keep on calculating the formula as given here. For example, if we go here, it would be the so say for example, once we go for this first row, right, house of index 1. So cost of say DP of 0 would be cost of 0, which is 11, and minimum of DP1 and DP2. DP1 here is 2 and 11, right? So this is how this minimum is calculated, and we came up with the same formula as we have derived here. Similarly, for DP1, it would be cost of 1. Cost of 1 is 14 plus minimum of DP of 0 and 2. DP of 0 is 14 and 11 for DP2, and we have to choose the same formula. So this is how the whole formula is working, and we keep on updating once we are done with this row, and then finally with the third row again the same formula will be applied, and it will update our this array. And once we have got final completed exhausted all the houses, we have got the final DP value having value of 21, 10, and 23, right? We have to return the minimum of this array. So because there are only 3 elements, we can do a very naive implementation of math.min and return the minimum of 3. So it would be DP 0 and then math of min again for DP of 1 and DP of 2. So this is all the formula about. Now let's solve this first using our example given. So I will create costs same as the array given. So array was like this. So let me copy this. Right. If I am using this form, so let me do. You just need to replace this with curly braces. This is how we initialize array in Java, like this. And yeah. Okay, so we have initialized this array. Just replace this square brackets with curly braces. And now call this method and pass this, right? Let's run this. Okay, the answer is coming as 10, which is correct and matching with our output. Now let's remove some unnecessary spaces here and let's submit this problem in lint code and see whether our solution is correct. Let me run the test first. Okay, test is working fine. Now let's submit it. Okay, so it's working well. So guys, this is all about this problem. Let's quickly calculate the time and space complexity. So the time complexity would be, I'm just using one for loop, right? So it would be O of n. And also we have optimized our space complexity. We are not using the 2D array for DP. We are only using single dimension array only with 3 elements. So again, it would be O of n. These are the time and space complexity. So guys, this was all about the paint house problem, which was our 16th problem. In the next video, we will solve the 17th problem of this tutorial series, which is Pascal's triangle. This is a very famous and very common problem for dynamic programming. And this is also our 17th problem in this tutorial series. See you all in the next video.